Hi, my name is Parisa Sargozy, and today I'd like to present Advancing Mixed Reality Game Development and Evaluation of a Visual Game Analytics Tool in Action, Adventure, and First-Person Shooter genres. In this work, we develop an analytic tool specifically designed for mixed reality games to assist developers in identifying and resolving gameplay issues effectively through its features including reconstructed gameplay sessions, heat maps, a comprehensive annotation system, and also advancing tracking for hands, camera, input, and audio, which provides in-depth insights for game analysis. Through its comprehensive feature set, Gamer allows the developers to pinpoint issues such as performance bottlenecks, level design flaws, and inconsistencies in player experience. By visualizing player movement and interaction patterns, the tool provides valuable insights that guide the refinement of the mixed reality games. With the rise of mixed reality and innovation comes challenges that traditional game analytics cannot address. Mixed reality devices with the narrow fields of view and inconsistent hand tracking require a different approach. Existing analytic tools are primarily designed for PC games don't fully capture the unique data that are coming from the mixed reality games, forcing the developers into time-consuming methods like manual gameplay review. This is where the Gamer comes in. Specifically designed for the mixed reality game analytic, Gamer addresses these challenges by simplifying the complex data into actionable insights and helping the developers to refine and improve their mixed reality games. The tool has two main components. One, the recording system, which captures the detailed data from the gameplay session and ensuring every interaction and event is logged for analysis. Second is the visualization, which allows the developers to interpret the recorded data through various visual tools. The main feature of Gamer is its playback system, which allows the users to seamlessly reconstruct the original gameplay session using the recorded data. Through the playback menu, users can analyze the individual player behavior with each player's data highlighted in a unique color. They can simply press the play button and watch as the dynamic objects move according to the exact time intervals captured during the session, providing a precise and insightful replay of the gameplay experience. Another feature of the Gamer is a 2D heat map to track and visualize the player movements within the mixed reality environment. Using the X and Z coordinates, the heat map highlights the player paths with a color scheme that clearly indicates the hottest spot and less explored areas. These visualizations provide valuable insights into player behavior and level design efficiency. And the next feature of the Gamer is the annotation system for efficient playtesting within the mixed reality environment. This feature allows you to label observations seamlessly, leveraging the speech-to-text technology to convert the spoken words into the text notes. To evaluate our tool, due to the lack of access to the open-source mixed reality game projects, we developed two games with the different genres, an action-adventure and an FPS game. In the first phase of the evaluation, we integrated the developed games with the Gamer Analytic tool to collect the gameplay data. Participants played both games while the Gamer recorded the player movements, interactions, and the game events. This phase involved 17 participants, age 18 to 33, providing crucial data for the next stage of our study. The second phase of the study aimed to address the key research question and evaluate the gamer's usefulness and usability across a different game context. We recruited 20 participants aged 18 to 37 years with a median age of 24. Using the same HoloLens headset from the first phase, participants analyzed each game level with the gamer, and each level was analyzed for 10 to 15 minutes, providing valuable insights into the gamer's performance and utility. In this phase, our main goal was to determine if the developers could actually identify glitches or problems in the games using the tool. Through the user interviews, we uncovered several issues in action-adventure game using the different features of the gamer. For example, users pointed out that some characters move unexpectedly because of unconventional button use which affected the gameplay. Or others mentioned that the players encountered characters getting stuck behind the map walls, disrupting the progress. Or the level design caused the problems with collecting the coins, impacting the player's ability to gather items. And in the first-person shooter games, users identified several issues as well, where the predictable enemy spawning patterns limited the player moving, reducing the gameplay challenge. Or the gun would become dislodged during the downward gaze or while retrieving items, disrupting the shooting experience. And some participants mentioned that the fast turns in the game led to the performance lags and loss of hand tracking, affecting the responsiveness. These issues underscore areas for improvement and demonstrate how the gamer can actually help identify the critical gameplay problems. The responses from participants across the various game genres were largely positive. We found that the action-adventure games were particularly well suited for the gamer, although the tool shows promise for applicability across the different genres as well. Gamer effectively identify bugs and issues within the mixed reality games, highlighting its potential as a valuable asset for the developers. It aids in the analysis and optimization of the gameplay experience. And with the further refinements and improvements, Gamer has the potential to fully realize its capabilities in the mixed reality field. However, the study faced some limitations. First, the convenience sampling method may limit the generalizability of our findings to broader contexts beyond the university settings. Second, the technical issues with the HoloLens 2, such as latency and field of view constraints, impacted the performance. Additionally, the focus on a simple games may not fully capture the diversity of all the game genres. So, to sum up, we developed and assessed the Gamer, a tool designed specifically for bug detection in mixed reality games aimed at game developers. After development, we collected data from 17 participants, focusing on two distinct game genres, which were action-adventure and first-person shooter genres. This approach allowed us to highlight the unique elements of each genre. Following this, 20 participants evaluated the gamer's effectiveness. They rated the tool highly for usability across both genres, as confirmed by our SUS scores and questionnaires, which can be found in more details in the paper. Semi-structured interviews provided further positive feedback and valuable insights as well. Despite some limitation in our study, the feedback affirmed gamers' usefulness for analyzing game across multiple genres. In summary, Gamers' development and assessment demonstrated its significant potential for mixed reality game analysis. The positive reception indicates promise, and the future iterations will refine and improve the tool based on the participant feedback to address any shortcomings. Thank you so much for listening, and for more details, please check out our paper, Advancing Mixed Reality Game Development and Evaluation of a Visual Game Analytics Tool in Action, Adventure, and First-Person Shooter Genres.